there's an exercise today. I'm going to demonstrate how to fit a few models of a personality test in Amos using confirmatory factor analysis, and then there's an exercise that gets you replicating that and fitting some additional models. And this largely mirrors what we've done before. So I've extracted the data from the repository online, and there's an exploratory and confirmatory data file in there. You could use either. I guess the logic here is that if you were going to sort of really play around with the factor structure, explore a whole pile of modifications, you might want to do that in the exploratory and then maybe go to the confirmatory later on and test it out. But yeah, that's just one sort of option. So if you double click on this file, it looks like this. So what we have is in SPSS, we have an SPSS file with, what is it, 1,236 cases and a bunch of personality items, A1 to O5. I think I've gotten rid of missing data. I'll just double check. That's probably going to make life a bit easier if I don't have missing data. There's a few things in Amos where it doesn't like missing data. And so, yeah, missing is 0, 0, 0. Good, okay. So yeah, we've got a personality test. We've seen it before. We've got 5 items per factor. We've got some reversed items. And ideally, it's meant to be representing the big 5. Last week, we ran exploratory factor analysis, if you recall. So let's just have a quick revision of that. 5 factors, let's say we're going 5 factors. And let's say we'll look at a Promax rotation. So, oh, yes, maximum likelihood. Yes. Yes, the speed. All right. So I would normally paste this, but yes, let's just have a look. Just to refresh ourselves that we got a pattern matrix somewhere that looked like this. And sure enough, it looked pretty good as a factor structure. So we had mostly loadings, well, pretty much everything loaded most on its principal factor, and there were only a couple of cross-loadings of meaningful size. So this is a good sign, and if we have a quick look at the factor correlations, we are seeing some correlations between factors. Anyway, okay, so that's what we see with exploratory. What we do at confirmatory is we really start to impose a structure on this data set. So I'm going to switch over to SPSS because Amos doesn't run on SPSS. So okay, let's close that. Imagine you're starting fresh. So to run Amos, you just go in here, Amos graphics. So that there's a few different Amos this, Amos that. Amos graphics is what we want. All right, so this is Amos. On the left, we have a drawing toolbar and various other features. In the middle here, we have tools for selecting drawing mode and output mode, groups, different models, standardized, unstandardized estimates, different files. And we've got our drawing pane. So we want to draw a confirmatory factor analysis model here. Up on the menus, we've got files to load data, load model diagrams, and save and so on. We can edit the model, various viewing options, drawing tools, analysis tools, and so on. Okay, so the first thing I want to do is I want to bring in the SPSS data. I want to connect the diagram to the data. So to do that, I go to File, Data Files, and I'll go File Name. And fortunately, I'm already in the folder, so that's good. You might have to navigate. It reinforces the idea that there's 1,236 cases. That's good. Okay, so now I am connected. My diagram is connected to the data. You see this little stack of white pancakes? It says list variables in dataset. Okay, so as you can see, we wouldn't see anything if I hadn't connected that data file. But now that I've connected that data file, we can see all the variables in the data file that we saw before. Specifically, we're interested in A1 to 05. So that's good. All right, we're connected. Now we want to start drawing models, drawing things. So we can draw observed variables if we wanted to. So I'll just go through this first and then we can move to actually doing a CFA. So we can draw rectangles. So for observed variables, remember you've got to press the mouse button down and then move and then let go. So you press the mouse button down like that. Yeah. Show of the truck. So you can select objects. You can select all the objects. All my fingers are up. You can select one object, one finger up. So I guess that's toggling the selection. Blue is selected. And that's nothing. So it's kind of cute. So I could select all the objects, then use the truck to move them around. Or if I only had selected one object, the truck would move just one object around. You can photocopy objects, so like that. Or if you selected all and you photocopied, I guess that would, yeah. Maybe. There we go. Beautiful. You can delete objects, well, you can cross them out. Bong, bong, bong. Oh. In theory. Yep, lovely. Keep deleting, please. Okay. So yeah, you can draw observed variables and latent variables. So say I wanted to draw something like this diagram here with the 3 observed variables and the latent factor. I could do this, and this is just briefly to show you the long way that you can do it yourself. You could say, well, look, I've got a latent agreeableness factor, and I've got some observed variables, 1, 2, say 3, and I believe the latent variable causes the observed one, so we'll draw, you select the directed arrow for directed relationships. So you can do that, and that, and then that, and then add residuals. Bang. Oops. So yeah, you can add your residuals. Isn't that nice? Doesn't look very pretty, and part of the art of Amos is drawing pretty. So you can use the magic wand to touch things up. That might make things a bit better. So it's sort of a bit better. You can rotate. Bless you. Staring at the sun in Amos. Okay, so you should be able to, I think you can make these things maybe rotate around somehow.
You have to click the arrow one and then click on it a few times. I
Yeah.
only figured it out 2 seconds ago.
All right, let's try. I'll move the truck. Move this down. That's not very pretty. So you should be able to kind of...
The one above the variables in dataset 1.
Whatever. I give up. So, all right, I'll leave that one alone. But
Can you just use the one up, the one from right-hand corner? The top.
yeah. So long story short, you can just use the one on the top. My point is that there's nothing special about the observed variables with a latent factor button. It's not adding a unique fundamental element. It's just a shortcut for doing something that you do a lot. And of course, yeah, you'd also have to, if you're going to do it this way, you'd have to constrain the loading of one of these arrows to be, and this is the real art, to actually select this arrow. Give it to me. Give it to me. Okay, there we go. So you can add a regression weight of 1, and that would constrain, give the latent factor a metric, and that would be good.
So what if one of these same things and just basically put them on and then alter them and tweak them a little bit?
There is an art to that, yeah, in terms of the sequence you do things and the copying and pasting. I'll show you what I think is about the quickest I can do a CFA, blah, blah. So, as Jasper mentioned, why not just use this icon? Exactly, that's what you should do. Just my point was that these are the, and sometimes you do have latent factors and components, you need to draw them individually, but if you are just setting up CFA, use this draw latent variable and indicator thing. So you draw a little ellipses. There's a real art to getting the size right the first time so that everything scales. So I'll go just maybe about that. And we've got 5 indicators, so I just go 1, 2, 3, 4, 5. Okay, so that's what we've got. I'll rotate that around so it looks pretty. Then we'll select all and move it up into sort of like the top.
Underneath the truck.
Yeah, so that allows me to spin these indicators around. Whatever works. All right, so to get to your point, Locke, around how do you draw these things efficiently, I know I'm pretty happy with that little cluster of 5 variables and whatever. So now I will create a photocopy of that because I know I'm going to have 5 factors. So I'm going to repeat that 5 times. So I'll select all and use the photocopy tool and get 2, 3, 4, 5. Okay. So yeah, using selection and photocopy, yeah. Obviously that would take a bit longer if you were to do it one at a time. So I'll deselect all. All right, next step is to get our observed variables into the right boxes. So we need to link Amos with the SMSFS data file. Like, well, we have made that general connection, but we need to tell it which observed variables belong in which boxes. So this is an observed variable box. If we go to text, we can see that it's got a name and a label. So if I wanted to connect that box with an observed variable in my data file, I need to match the name with the name in the data file. So C1. So I could do it directly like that, and that's connected now to this C1, whatever it is, I'm a hard worker or something. Now that's okay, but a better approach, probably more reliable, and it also means that you get the variable label copied across, is to drag and drop from here into these things. So if you take C1 and drag it in, we see that it's copied the variable name and the label. And it also makes sure I don't make any typos, because that's kind of frustrating when you've accidentally typed D1 instead of C1 and nothing works. So yeah, best thing is to drag and drop all your variables. Let's get this a little bit closer. It's a little bit of hard work really, but yeah, we're just dragging it all in. Now before I keep going, you notice it's kind of nice to see the raw text, but it's also a bit messy with all that text overflowing like that. So one thing you can do is hide the variable labels. So if you go to View, Interface Properties, MISC, Display Variable Labels, Apply. Okay, so that's just, probably most of the time that's going to be a bit easier to read. And so, bit tedious, but I'll just copy them in. So we're just connecting each variable with its corresponding thing. What we've got here at the moment is 5 latent factors. Each item loads on one and only one factor. Furthermore, there are no correlations between latent factors at the moment. So it's saying that each of the big 5 is independent.
Does it
Looks like I've missed agreeableness at some point, but anyway. And that can happen, what happened just then, where I didn't quite drag it in, and that's not something you want. Quite often there'll be like hidden little variables floating around when you've accidentally created something in the background and can cause problems.
And if all your boxes are really squashed together, how do you get them out?
One strategy is to start again. That's probably the best. If you get it right at the start, it's probably the simpler than trying to recover it. Yeah. Yeah, you can use this change the shape of objects tool to sort of go like that.
Okay. Makes it a really weird size thing.
And you can select multiple objects at once and apply that, and it'll change everything at once.
Oh.
But all right, so we've got all our observed variables in here. That's good. We've got the starting point. Next thing we need to do is name our latent variables. So we need to name this first one. What is it? It's probably conscientiousness. The big mistake that occasionally occurs is if I called this conscientiousness, I'd have a problem. Does anyone know why I would have a problem if I labeled this conscientiousness? Sorry?
Oh, sorry.
Oh yeah. Oh, sorry. Okay.
No, it doesn't match up, does it?
Well, the problem is it does match up.
Oh.
So with latent variables, we're not mapping the latent variables to a variable in here. It's a latent variable. It's something that's being estimated by Amos. So the one rule, well, probably a few rules, but the main rule is don't name your factors a name that you have in your data file. So that occasionally you get issues if you've scored your test manually and then you go and do that. So I'll call it something like consk or something like that. So that's there. So we'll call it, instead of extroversion, I'll just call it extra and neuro and open and agree. Okay, so that's good. We've got latent factors that are now named, so they can be estimated, and they don't conflict with anything in the data file. Okay, do you remember about the ones? Do you remember what I said about the ones and what the issue with the ones was when you have reversed and non-reversed items? You need to check that the item with the 1 is a positively worded item. Otherwise, you're going to have, I don't know, what's unconscientiousness or introversion or emotional stability or conservatism or disagreeableness. So we'll just go to whatever the item's getting the 1 and just check the text. I'm exacting in my work. That's conscientious. I don't talk a lot. Ooh, that's a reversed item. So I'll have to find that's find it difficult to approach others. Know how to captivate people. All right, so I've got to get the 1 off what it's on and onto this one. So go to parameters, regression weight, put the 1 there, and go to where it was before, take it off. So now it's going to be deriving its meaning and its directionality from a positively worded item. So I'll do the same, just check neuroticism. Get angry easily, that sounds like neuroticism. I'm full of ideas, that sounds like openness. And am indifferent to the feeling of others, that's no good. Inquire about others' well-being, that's better. So we'll put the 1 on that, and we'll take it off what it was before. Okay, so now it's starting to look good. Actually, I'm getting a bit paranoid, so I will save this model. So I'll save it. Another tip. Give your models good names. I generally adopt a numbering system for my models as well as a descriptive name. So I would call this, for example, model 1 or O1, and a description might be just 5 factors uncorrelated. So I'll call it that. So that's got an AMW extension. Okay, so we're almost done. All we need to do is name these unobserved variables. there's a trick that if you've named all your variables already, you can go to plugins and click Name Unobserved Variables. And if you don't care much about what names the residuals get, this is pretty handy. It just gives them names like, well, normally it would give it E1, E2, E3, E4, E5, E6. It's just a name for the residual. You notice it didn't give it E1 because we've actually got variables called E1 to E5. This is fine if you're not going to do anything with the residuals. If you're going to look at modification indices involving residuals, you probably want to give them better names. So if you want to know, oh, maybe I should have a correlated residual between these two items, it's probably better to have a name like something like, I don't know, for item 1, we'll call it RC1, like residual C1, and residual C2, and residual C3. And that way, when you look at the Amos output and the modification indices tell you, you should be correlating, you know, RC4 and RC5, you go, well, I know what that means. You know, I don't have to get too confused. So that's probably a better way of naming your residuals if you're going to be really doing things with them, but I don't know. It's up to you. I guess it's a matter of what's quicker overall. But yeah, maybe you could keep going with that, but maybe that'll suffice for now. All right. So let's run this model. Let's start actually seeing what Amos tells us. To start with, I'll be like a naive person to start with, like who's never used Amos. I'm like, well, let's go, let's run. So I go to the abacus and I click run. First thing it does is it gives me a warning message. This is just telling me that none of my latent factors are allowed to correlate in my model. So I haven't let extroversion correlate with conscientiousness. And that's fine, but it's just telling me, oh, are you sure that might not necessarily be a good idea? And often it's not. So, but you can certainly do it. So it's just a warning. You can ignore. So we've ran this model, and you notice now, success, we've got this red up-facing arrow. So if we click on that, we move from just viewing the model drawing mode to actually getting numbers. A little hard to see, but maybe if we use this little, where is it? Oh yeah, here we are. So you can have a little magnifying glass and see. So what we've got loadings of the conscientiousness factor on each item. Some sort of, I think, variance estimate for the conscientiousness scale, and variance estimates for the residual. Okay, so you notice that doesn't look much like what we're familiar with from EFA, and that's because it's unstandardized loadings. So probably what we want is standardized loadings, right? Like kind of like the correlation between the item and the factor. All right, so what would you do there? Well, unstandardized estimates, standardized estimates. All right, so I'll go to standardized estimates. Hello, there's nothing there. Okay, so that's the first error that everyone makes when they're first using Amos. They go, where's my standardized estimates? I want standardized estimates. So yeah, of course, the trick is Amos doesn't give you every bit of output by default. You have to ask for it. So what you would normally do, instead of diving straight into running the model, you would go to analysis properties. If you have missing data or you're interested in estimating means, then you'd probably click estimate means and intercepts. Doesn't really matter here too much because we don't have missing data and we're not that interested in means. We can choose our estimation method. Maximum likelihood is the default, and not too bad. The output tab is probably the main one of interest here. We certainly want standardized estimates. That's the core. And there's a whole bunch of other stuff you could ask for, like modification indices. If you're running regressions or structural equation modeling where you're predicting things, you might want to know the variance explained. This will give you your sample correlations and covariances, implied correlations and covariances between latent variables, I don't know, whatever. Here's your indirect effects. You can get tests of normality, all that sort of stuff. Okay, so let's run this model now. So we've got the red up arrow, so that's good. We're in standardized estimates, so we've still got our unstandardized. But if we go to standardized, we're probably going to get something that looks a bit more familiar. Okay, so now we've got here what you might think, what you'd think of as factor loadings. So, for example, if you go back to, what was it, A1, so it was what, the first item was a negatively worded item, so that's got a 0.41 loading, 0.68, 0.77, 0.52, 0.60. Just out of curiosity, and I haven't even checked this, but I wonder how that compares to the EFA. So 0.449 was the negative one, then 0.6, 0.6, 0.4, 0.5. It's not identical, it's not the same model, but it's quite similar. Negative and then sort of 0.6 kind of loadings.
Is that because Amos estimates the error or takes into account the error a bit better? Why is it different?
I think it's mostly because the factor is defined in a different way. With SPSS, there still are cross-loadings. In this model, there are no cross-loadings, not even small ones. And so the centroid, or exactly where the factor is, has kind of moved around, and therefore the relationship with the items has moved around a little bit. So yeah, there's a similarity, but this is kind of a model where we're constraining all cross-loadings to be 0. Every single cross-loading is 0, and furthermore, we're not allowing any correlations between factors, which our Promax rotation allowed. But the logic remains. You're checking that negatively worded items have negative loadings, that all items are loading reasonably highly. Alrighty, so if we go to the View Text button, that looks a bit like a spreadsheet, we can actually view the output. So I don't know if there's... So it tells us that there are 350 sample moments. So this would be all the covariances defined between the 25 items, probably all the variances, and depending on whether we've estimated means or not, you might have them as well. We've got 75 parameters in the model, which would correspond, I think, to... Oh, this is going to test me. Let me just check that. Number of distinct parameters to be estimated. So I think we'd have 25 loadings effectively, or maybe 25 error variances. And if we estimated means, we've probably got 25 means we're estimating as well. So that's kind of 3 parameters for each item. We have a chi-square measure of fit and the degrees of freedom, which is the difference between the number of sample moments and the number of parameters that are estimated. We can certainly, where are we? You can see all your regression loadings here. So this is just further information beyond what you get in the graph. You get the unstandardized loadings or standardized loadings. So that's just the same information, but in tabular format. You could probably, I think you could copy that into Nope. So you can copy that into Excel or something like that if you were going to develop a, oops, if you were going to develop a report or something like that. So you want to report your loadings. So yeah, there's a whole range of sort of properties. Some are more interesting than the others. I think the main thing of interest here is the loadings. Yeah, so the next big thing probably that will interest you is the model fit. And often you're interested in particular model fit information, like the chi-square, which they call C-min, the things like RMSEA and CFI and a few others. So the default model is the model that we've just run. The others are kind of, the independence model is like, there's no relationships between anything and it's not that interesting, but it's used as a frame of reference. So the main one we're taking out here is the default model. So we could even start to create a little table, and this is probably what I'd recommend you do. Let's say 5-factor uncorrelated, and record your chi-square, I don't know, your DF, your RMSEA, RMSEA lower, RMSEA upper, CFI, maybe SRMR, and basically go through this output and pull out the bits and pieces that you want. So chi-square 3019 or whatever, degrees of freedom 275, RMSEA, wherever that is, 0.9, 0.87, 0.93. Oops.
What's the
It quantifies the uncertainty due to just your samples being an imperfect estimate.
What would make that point or bigger?
So it gets smaller as your sample size gets bigger. So bigger sample size, more precision in estimation. So for whatever reason, it defaults to oops, what am I doing? It defaults to 90% confidence intervals. It's some sort of funny quirk of history, I think. Yeah, I think other software will give you 95% or whatever. But so yeah, and you can get CFI in here somewhere as well. If you want SRMR, you have to rerun the model. I think it's, what is it, plugins, standardized RMR. So you click that, and you get nothing, and you go, oh, my Amos is broken. No, that's not the case. You just need to rerun it with that box open. Don't know who decided that was a good way of doing things, but that's how you do it. And then with the box open, you run it, you get that extra number. So 0.1, 0.142 or whatever, or 3. And I can't type. So yeah, so that's sort of a way you would record the details of one model and then iterate with more models. So to illustrate the idea of running more models, I'll save this model, so it's there, and then I'll save it as a new model. So I don't want to overwrite my original one. So I'll go, okay, I'm going to have a second model, 5 factors correlated. So what I want to do is I want to allow the factors to correlate and see if that improves the model. So I can draw arrows like this, one at a time, dragging and dropping. And that's not bad, that'll work. You could do it for all of them, but a little trick is to select all the factors you want to have every intercorrelation for, and then go to plugins and draw covariances. So that just does all possible pairs. So now that's model 2, I think. Yeah. So I can rerun that now And if I run that, if I look at the output, I can see that yes, I have correlations between my factors. There's a 0.65 correlation between extroversion and agreeableness, for example. So it certainly seems, given like there's some fairly substantial correlations, that should be improving the model. And I could go into the output. Oops. And pull out those that fit information. So now we've gone down to 2229. So 5-factor correlated is 2229. So we've improved things by 800. Some say that if you improve by more than, we've changed our degrees of freedom. We've added 10 additional parameters for the 10 additional correlations. Some people say, oh, if you're improving by about 2 times the degrees of freedom, if you're improving by more than that, then it was a worthwhile change. So we've added 10, so we've improved by more than 20. That's a rule of thumb. We've improved by 800, so it's clearly a much better way of representing this test.
It's a chi-square test. Is that this table of t values and all that stuff? You're looking at
Yeah. You can either do a formal model comparison, or you can look at this as a chi-square. So you can subtract this from this from this, and look it up and see whether it's a significant chi-square. So this is what that's the difference, and that's the difference. So you could look up what 790 is on a chi-square distribution with 10 degrees of freedom. It's going to be massively significant. Probably like 30 or 40 would be significant, or maybe less. But yeah, that's what you're getting at. Yeah. So that's a way of doing model comparison. So yeah, you go ahead and record that information. A little trick. It's all about the tricks, I guess. You can get a lot of this information in the model diagram if you add it to the title. So this is quite a nice thing to do. Every stat has a little shortcut. So chi-square equals /cmin, or RMSEA equals RMSEA /RMSEA. Let's put it over there. Truck it around. So, okay. So if I run this now, that little /cmin should get replaced with the actual value. So that's a little handy trick. If you're wondering how did I know that it was /cmin /RMSEA, you can go to the output model fit, click on any of these things, and it will tell you. /cmin is the text macro, or if you wanted to get the lower and upper bounds. I don't know actually how you get the lower upper bound. Running out of space. Surely there is one for that. But certainly the others, there's like P close and all that sort of stuff.
So how did you do that again? What did you click on to enter the? Sorry, CMA.
So this title thing, is that what you mean? Like if you go to title?
Yeah.
Yeah. So that's where you can literally add a title, like 2-factor uncorrelated, or sorry, 5-factor correlated. But yeah, you can also add a lot of those little things you might want to quickly extract. Final thing I wanted to talk about is modification indices. So this is where, you've got a pretty good model and you want to get some suggestions for making it even better. So I have requested modification indices in the analysis properties. So when I run this, and I go to my output, you can see that there's a bunch of suggestions for how I could improve this. And there's different categories of covariant modifications. So I think all these regression weights will generally be cross-loadings. Is that right? Yeah. So yeah, you often want to look through which ones are the biggest. Either certainly I would typically rank order them by their type and think about the largest ones that it seems sent. I generally would copy this into how do we get it? See if this works. Copy, put it in Excel, give it a name, var1, oops, var2, oops, let's make a table out of it. Hopefully I know how to do that on Windows. Okay, that worked. And then I will sort by modification from largest to smallest. And we can see like what modifications would have the greatest improvement in chi-square. So it's saying that if I let N4 cross-load on extroversion, I can improve my model by 121. And often you'll see a sort of relatively like some big changes that'll make big improvements, and then that'll often be very sensible, and then a break at some point where it sort of seems like, oh, it's almost like looking at a scree, I think. You know, it's like, well, that's not really going to make much improvement.
Why do you want to do that theoretically?
It is a bit of an art one. I mean,
Like, so like I could just make everything correlate.
Yeah, and it is one of those fuzzy things. Like, I mean, there can be strong logic. You can say, oh, actually, that N4 item, and
It's often feel blue, so I think it's talking to that happiness extroversion.
yeah, the happiness perfect, yeah, happiness extroversion, that, whereas they've got other more anxiety-based neuroticism items. So there'll often be an explanation to it. So obviously, it's a better representation of what's going on.
What does it actually mean when you say let it covariate?
It's saying that if I add a cross-loading between, I'll say this as model 3, 5-factor modified or something. So it's saying if I were to add the cross-loading between extroversion and 4 with it, it would improve my model quite substantially. It's saying that probably the case is that N4 correlates with other extroversion items. And so by preventing that, I'm sort of not representing the relationship between...
If N4 is negatively worded, it doesn't matter, does it? Because your one's still on a positively worded one? Because like that's negatively worded for extroversion.
As long as it's unconstrained, it will do whatever it wants.
It doesn't matter. Because you've just got
Yeah.
a positively worded one.
So yeah, I guess we're saying this is going to be negative, aren't we? So if we run that, we get a negative 0.33 loading. We could even like have a quick just check, and whoa, there it is. Often feel blue, cross-loading on extroversion. So there's definitely a connection there between, you know, what's cross-loading naturally versus going into confirmatory and saying, well, what would improve this model? Well, allowing this to cross-load would represent the relationship between the items in a better way.
Does that mean if you were scoring that personality test, you make a suggestion to the test makers that this item should be scored on both scales?
Yeah, you could. Yeah, I mean, it's a dilemma, isn't it? Alternatively, you could say, is there something wrong with this item? Or maybe even the test is probably maybe not centered right. Like, yeah, there's all those kind of issues, like whether you want to modify the test or do you score it that way? There's trade-offs with double scoring items on factors. It has issues in itself that you can sort of induce correlations between scales because an item's being counted on both. So there's that question, but
So if you found that, would you say, well, this personality test is rubbish, we should use it?
I've seen rubbish, and it's a lot worse than this. I've seen a lot of rubbish working in consulting settings where, yeah, it's just awful. You know, cross-loadings all over the place, little dribbly-drabbly factors down here, stacks of cross-loadings, items not even loading on their main factor, but several items loading on the wrong factor. So this is like,
using bad measures that they've just developed and knocked together.
yeah, the client says we want this item, we like this item. I mean, yeah, there's other priorities sometimes besides factor analytic purity. But yeah, if you go into organisations, you'll definitely see some messy factor structures, particularly if the scales haven't been designed with like clean factor structure in mind. Anyway, I probably should stop talking and turn it over to you. I feel like I've been talking for a long time now, but I guess what I've been trying to show you in Amos is a quick overview of how it all works. It is the kind of thing where it is a lot to get through in one day, so you may well need to kind of read up a bit more and study Amos a little more. But the logic is that we're building models, refining models, and hopefully learning something about the structure of a test through these different model comparisons. So yeah, I think it's over to you now, I guess. Yeah.